Now we're going to look at an example where we solve a system using the addition method. So in the addition method, what we want to do is we want to manipulate the equations so that when we add the equations together, a variable will cancel. So when I look at these two equations, and up here it says, for under the addition method, create opposite coefficients for one variable. That's what I mean by manipulate the equation. So when I look at these two equations here, I can see I have 2x plus 3y and a 5x minus 3, or a 5x minus y is equal to negative 26. I'm going to try to eliminate y. It doesn't matter which variable you try to eliminate. We'll see other examples where I eliminate x. But in order to eliminate y, if I have this positive 3y right here, I would need to have a negative 3y right there in order to eliminate it. So what I'm going to do is I'm going to multiply both sides of this equation, the second one, by 3. Because multiplying both sides of that equation by 3 will give me those opposite coefficients. So I'm going to multiply the 5x by 3, which will give me a 15x. I'm going to multiply the negative y by 3, which will give me a negative 3y. And I'm going to multiply the negative 26 by 3, which will give me a negative 78. So now what I'm going to do, and a common mistake I see people make is they'll multiply by 3 on this side, but then they won't multiply that number by 3. So make sure you multiply everything in the equation by 3. So now I'm just going to rewrite these equations. I'm going to stack them on top of each other. 2x plus 3y equals 10. That's the first equation. The second manipulated equation is 15x minus 3y is equal to negative 78. And now we're going to use the addition method to add these two equations together. So adding 2x plus 15x is 17x. 3y plus negative 3y is 0. It's completely gone. It's eliminated. That's why it's sometimes called the elimination method. And then 10 plus a negative 78 is a negative 68. Now we have an equation that is only in x. So we can solve for x in that equation by just dividing both sides of this equation by 17. And we see that x is equal to negative 4. So we know x is equal to negative 4. Now to find the value of y, we can substitute in x equals negative 4 into either equation. We could use this equation or we could use that one. I'm going to choose to use the first equation just because. 2x plus 3y equals 10. I'm going to plug in that x is negative 4, so I have 2 times negative 4 plus 3y equals 10. So I have negative 8 plus 3y is equal to 10. I'm going to add 8 to both sides of this equation to get that 3y is 18. And then I will divide both sides of the equation by 3 to get that y is equal to 6. So I can see that we have a solution of negative 4, 6. I'm not going to graph this because this is actually the exact same graph. I didn't mean to put this on the paper. But the purpose here is I showed you how, one, we could solve the system using substitution, and two, we could have also solved the system using addition or elimination. One thing that I will point out here is typically if I look at a system of equations and one of the coefficients has a variable of 1 or negative 1, I will probably try to do substitution because it would be really easy to solve for that y. If all of the variables have coefficients, like in example 5, all these variables have coefficients, I would probably not try substitution on a problem like that because and we're going to do example 5 in a second, but just really quickly, say you want to solve for that x. You would subtract the 0.3y to the other side of the equation. And then you have to divide by 5. And then this is what the equation, this is missing a y. And then that's what the equation looks like for what x is equal to. And that's not particularly pretty to work with. Right? So generally speaking, if all of my coefficients have if all of my variables have coefficients, I'm probably going to try to do the addition method and manipulate the coefficients so that we can add the equation together.